6.3b, we are continuing with our vectors, but specifically today, we are going to talk about the unit vectors. And a unit vector is just any vector with the magnitude of 1. A key word being unit, unit being 1 unit. It doesn't have necessarily kilometers or everything. And the unit vectors are important because we use it in physics in terms of scale, comparing one scale force to another scale force. And it is easier to compare everything if you take the magnitude and we push it all into 1 unit scale in order to compare degrees of force and what have you. So that's why we are learning the unit vector, and that's why we are applying the unit vector. So let's start off with some examples. So say we have a unit vector u, and in the direction of v, and we want to verify, how do we find the component of u to make 1? So what does that mean? So let's say v equals 0, -9. Okay? So v is here. V is here. If we push the magnitude all the way out here, it is not 1. But if we start off here and we want a u heading towards v, but we want to scale that down to the unit of 1. What does u have to be in order to have the magnitude of 1 facing that same direction if v is at 0, -9? Well, the formula that we use to find the unit vector is we take u equals 1 times the components of v times v itself. And little quick reminder, v is 0, -9, which is v. So then we just got to plug in with our formula, 1. Remember, we have this is our magnitude of v. So our magnitude of v is then, we use the distance formula. So this is 0 squared plus -9 squared times 0, -9, the components of 9, which is 1 over the square root of 9 squared is 81 over times 0, -9. Simplify that some more, equals 1 over 9 times 0, -9. So now we just got to take 9 times, 1/9 times each part. 0 times 1/9 is 0. 1/9 times -9 is -1. So my u has to equal 0, -1, which makes sense. It's in that same direction, but notice that the magnitude, the unit, is just 1. Let's do another example here using the same idea. Let's say we have v equals 12, -5. So if I graph this is 12, -5. So it kind of look like this. So we want something from the origin, a u, which kind of goes in the same direction, but the magnitude is only 1. So we use our formula, which we have. So u equals 1 times the magnitude of v, 1 over the magnitude of v times my v components, which is 1 over magnitude is the distance formula. So we use 12 squared plus negative 5 squared times 12 times negative 5 in the components. 1 over 12 squared is 144 plus 25 times the components. 144 plus 25 is 1 over 69 times 12 negative 5, which is 1/13. So now 1/13 times 12 times negative 5, well, it doesn't divide evenly, so I'm just going to leave it as fractions. So u should equal 12 over 13 and negative 5 over 13, just like that. Let's work outside of our unit vector. What if we are given a vector in the linear form? So our linear form has an I and a j. So this is negative 5i plus 16j. And we want to find the magnitude and direction angle of this linear form. So just to kind of remind you, this is also the same thing as the component of negative 5 comma 16. Just a quick reminder, so our magnitude is our distance formula. So we write magnitude like this. Distance formula, negative 5 plus 16 squared. So this is 25, well, negative 5 squared, 25. 16 squared is 256. So this gives me my magnitude of V is, or we say magnitude, is the square root of 281. It doesn't factor well, and I don't believe there are any perfect squares in 281. So that is just my answer, the square root of 281. I want my directional angle. So if I do draw a triangle here, so think about this here. This is negative 5 up 16. So then to find the degree, if I draw that angle, okay, and it's a theta right there, makes this triangle. We know our opposite and we know our adjacent, our opposite being 16, our adjacent being negative 5. We can find our angle because our tangent of theta should equal 16 over negative 5. So our theta should equal the inverse tangent of 16 over negative 5, which gives us an answer of, once we put that in, punch that in, we get the answer of negative 72.6. However, that means, remember, our tangent is, when we get an answer, it assumes that we're going here and there in terms of positive and negative. But we know it's in our second quadrant, so I'm going to take it from here, 180, and it's going to go negative 72.76. So I take 180 minus that. And it should give me my theta as 107.4 degrees. What if we were given the format in a different way? So let's say our vector V is given as 9 times the cosine of 80 degree I plus the sine of 80 degree, 80 degree J. What does that mean? Well, we already know that I and J are equivalent to the X and the Y, and sine is X, and no, sine is Y and cosine is X. So they are already paired up. So if I had to figure out the magnitude, it's already given to us. Our magnitude is 9, and our angle is then just 80 degrees because everything is already given to us. What if you were given the magnitude and the angle, and then you have to find the different components? Let's say the magnitude is 9, and our angle right? Our angle here, theta, is in the direction of I plus 7j. So this is the direction. And we want to find the components. So we want to find this and this. To do that, what we do is we take our magnitude. So here we have a 1 and a 7. We take our magnitude, and we divide it by our distance formula. So here, right, put this. So here are, and our magnitude times our directions, times the direction. So this gives us, for the first one, first component, 1 times 9 all over 1 squared plus 7 squared, which is 9 over 50. And 50 is 25 times 2. So this is 9 over 5 root 2. And then the other one should then be 7 times 9. So it's 9 over 5 root 2 for our first component. And our second component is 7. We'll just change on the top where it's 7 times 9. 7 times 9 is then 63 over 5 root 2. Last example here, if we are given 2 vectors. Okay, so let's say one vector u, the magnitude is 24. The angle of u is 45 degrees. Next vector v, the magnitude is 50, and the angle of v is 180. So let's kind of, before we start, let's draw it to see what that means. If we start with u, and it's at 45, so let's say it's 45 here, and the magnitude's 24, so this is 45 to 24. And then here, from this point, we want to go 180, so this way, in the magnitude of 50 degrees. So I know my answer is going to be somewhere here. The combined two forces will push you in that particular direction. But we got to find the components of that, of what that actually means, of this, what is the components of this particular one. Well, to do that, we have to first find the components of u and the component of v. So u is then, to find that component, we just take 24, and the x, we take cosine of 45. Our cosine of 45 equals root 2 over 2, so this is 24 times root 2 over 2. So this simplifies to 24 divided by 2, so this is just 12 root 2, okay? So our x-coordinate is 12 root 2 for our u, so 12 root 2. Our y-coordinate is then 24 times sine of 45, which is also, so this is 24 times root 2 over 2, which is also 12 root 2. So we have 12 root 2 and 12 root 2 for our u, the components for u. So let's do our components for v. Remember, v is 180 degrees or pi, and the magnitude is 50. So v, the components, so first let's do that. We do 50 times cosine of 180. Remember, cosine of 180 is negative 1. So this is actually just negative 50. So the x is negative 50. The second component is sine of 180. Sine is 0 in of 180 degrees. So this is actually just plain old 0. So now let's put this together. We want the sum of the two, right? We start off at u and then we go to v. So we just add the two. So the sum of the two would be 12 root 2, right? Plus negative 50, which is 12 root 2 minus 50. And then 12 root 2 plus 0, which is just plain old 12 root 2. And that would be our answer.